Today I'll walk you through a strategic approach to testing and monitoring data products, with a focus on data observability. Briefly about us at SYNQ, we've built a data observability platform to tackle the challenges of data product reliability head-on. Our guide, The Definitive Guide to Building Data Products, distills best practices used by leading companies like IAG, eBri, and Avon. Let's explore how to apply these strategies to your pipelines. Let's start with the why behind better testing. DBT surveyed thousands of practitioners, and the top pain points were clear: ambiguous ownership at 43%, and poor data quality at 41%. Having worked with multiple data teams, I can confirm these are real blockers. Data products can address these challenges, but first let's unpack why we're facing these issues, and what's changed in the data landscape. The modern data platform is now the backbone for a wide range of use cases, for example, revenue reporting, exploratory analysis, operations automation, forecasting, AI applications, embedded analytics, and marketing automation. As analytics platforms support more use cases, they've become increasingly complex. Some companies now manage tens of thousands of models, with intricate dependencies across pipelines. Data teams have succeeded in making analytics indispensable. Use cases like operations automation, forecasting, and marketing automation are now business critical, a shift from the days of ad hoc reporting and exploratory analysis. But with this success, the stakes are higher, and failures in these critical areas can have significant impact. With critical use cases relying on the data platform, there's increasing pressure on quality. This means a sharper focus on data testing, anomaly monitoring, ownership clarity, incident management, and defining test coverage with SLAs to ensure your data products meet the demands of the business. Let's break down the quality challenge. Tests are often deployed mechanically, lacking intent, like basic, unique, or not null checks. Meanwhile, testing in the transformation layer often duplicates observability layer monitors, and a crude test-all strategy creates redundancies. This leads to alert fatigue, overwhelming data teams, and making it hard to prioritize what matters. To address these challenges, we need a focused strategy with data products. Take IoT analytics, a business-critical use case. It lives in the analytics platform as a collection of assets across systems. By anchoring it in observability as a data product, we can drive strategic testing and monitoring deployment, summarizing test and monitor performance with a clear status, ultimately boosting reliability for the use case. This brings us to a data product reliability workflow. We start by capturing a use case as a data product, defining what drives business value. Then we clarify accountability through ownership, deploy a targeted testing and monitoring strategy, manage and resolve incidents, and review quality metrics to identify trends and iterate continuously for improvement. The first step is identifying your data products. These can be core business metrics like a finance mart in DBT, business processes such as CLTV models for marketing, dashboards for KPI reporting, or key high-priority models. As Steen from Avon notes, data products need to capture granular dependencies, like attribution data within marketing, to ensure quick action when issues arise. Defining data products brings clear benefits. Instead of managing hundreds or thousands of dependencies, you can view them at a high level through data product groupings. This helps identify circular dependencies, simplifies tracing issues, and clarifies who to notify during incidents, prioritized appropriately. At SYNQ, we also distinguish between producer data products, which read from sources and power others, and consumer data products used directly by end users. Let's try to work through the entire workflow with an example that we're familiar with. It's our user-facing analytics in the SYNQ app. We have a DBT model that powers a customer-facing dashboard, showing data health over time per customer. We don't want this to be wrong, so we've applied the data product observability workflow to test and manage this. We follow the SYNQ framework. Firstly, we take the first two stages, the definition of the data product in question and ownership. We define data products in DBT by organizing them into marts, grouping models by folder for clarity, like app analytics. We assign ownership in DBT groups, linking to observability for alerting, and set severity as P1 for user-facing products to ensure clear accountability and prioritization. With data products defined, we can deploy a strategic testing strategy. We developed a conceptual model splitting our pipeline into operational systems upstream through to marts, and products as the final output. This aligns with team ownership. Engineering handles upstream, DBT developers manage aggregates, and technical account managers oversee downstream, notifying customers of issues. Using this, we strategically deploy tests as layers of defense, targeting specific pipeline stages to prevent issues effectively. At the source stage, where upstream systems can be a wild west outside our control, we apply an engineering mindset to anticipate failures. We deploy DBT tests like not null and completeness, paired with anomaly monitors for volume and freshness, often at the table or segment level. This ensures issues are caught before transformations, likely pointing to upstream problems. Many customers focus most tests here, often using data contracts as blocking agreements, not just tests. In SYNQ, we set rules auto-adding freshness and volume monitors for sources upstream of data products. Since we've tested diligently at the source, we can be less paranoid in the transformation stage. We follow key principles, minimize anomaly monitors here. Most issues should be caught at the source, avoiding alert clutter like hundreds of freshness alerts from a single failure. We also avoid retesting not null checks already done. Instead, we focus on 2 areas in the data warehouse, ensuring joins don't break or duplicate by checking row counts, and testing only derived columns with new logic, not pass-through ones, to keep testing efficient. Now at the marts and product stage, with operational systems, sources, and transformations already tested, we focus on business logic from an end-user perspective. We add fewer but more thoughtful tests, like ensuring the number of controls exceeds issues, as shown here. These tests, often added by domain experts like analysts, validate what the data means to the business, not just its structure. This also enables a clean ownership handoff. Analysts define business-focused tests, while data engineers handle upstream operational checks. We've mapped it dependencies and deployed tests so quality comes from their combination. At SYNQ, we view quality as a sum of controls, giving us a P1 testing blueprint, reconciliation with ops, deep source testing, specific tests for joins and transforms, and business logic in marts. This also provides observability insights. We calculate a quality score based on failures on or upstream and track test coverage, like the 124 tests here, giving a clear feedback loop for the data product. Defining critical data products significantly enhances incident management. For example, a colleague's inefficient DBT model failed due to an overcommit tracker, but SYNQ didn't send alerts. It was a prototype with no platform impact. In contrast, an anomaly monitor flagged a data drop in a DBT ingest pipeline, which did impact critical downstream use cases. With data products operationalized, we can instantly assess impact and notify engineers, ensuring focus on what truly matters. Revisiting our initial challenges. Instead of mechanical testing, we now have specific, targeted tests. Our tests and monitors complement each other, and we focus on pipelines impacting our key data products end to end. This product-centric approach has helped many teams reduce alerts by over 80% while catching more issues, making incident management far more effective. For deploying at scale, a data product-centric approach shines even in complex stacks. Data products are designed to rely on each other, like revenue metrics feeding into finance, allowing this process to repeat seamlessly. At any point, we can assess failures, communicate impact to engineers, and track coverage and quality. This structured approach avoids the spaghetti mess of lineage, providing clarity and observability across the stack. Thank you for joining. To dive deeper, download our Data Products Reliability Guide. Scan the QR code to get started. Let's keep building reliable data products together.